This is our video for Unit 8, Day 3. So we've been talking a lot about right triangles using Pythagorean theorem. What we're going to be doing today is talking about two types of special right triangles. These special right triangles you'll see again when you take Math 2, again when you take Math 3, and they're triangles that pop up a lot when you take the ACT and SAT. So there's two kinds of special right triangles we'll go over. The first is called an isosceles right triangle. So isosceles right triangle. This triangle has a right angle, so it's a right triangle. It also has two congruent sides. So two congruent sides are what makes it isosceles. For instance, right has a right angle, isosceles got two congruent sides, so isosceles right triangle. So just like with other isosceles triangles, the two base angles are equal. So an isosceles right triangle, they're both 45 degrees. So since the two angles are 45 degrees, it's a right triangle, we have a 90-degree angle. This is also called a 45-45-90 triangle. Right, and those come from the angle measures. So why these triangles are special is because they always follow a pattern. We call this the side pattern. So the two legs of the triangle, we'll start by calling x to start our pattern. So if this is x, the other side has to be the same, is also x. The hypotenuse, which is the longest side, is across from 90-degree angle. That's equal to the the short one of the legs times the square root of 2. Right, so they're both the same, so it's equal to, there's no shorter leg, it's equal to the leg times square root 2. So this side is x, the other side is x, the hypotenuse is x square root 2. Right, so if this leg was 1, this leg would also have to be 1, and then the hypotenuse should be square root 2. If this side was 10, this other side would also have to be 10, and the hypotenuse would be 10 square root 2. Right, so these are just examples. If we saw the hypotenuse was 50 square root 2, that would mean each of the legs were 50. Right, so they're always going to follow the same pattern. Right, and even if it's a bigger or smaller triangle, it will always follow this side pattern. So the way we describe the side pattern is we can say x, x, x square root 2. Right, and each of these sides lines up with the angle that it is across from. So the 90-degree angle is across from the square root 2, the 45 across from the x, and the 45 across from the other x. We could also call this side pattern 1, 1 square root 2 to make it easier. But we'll always have the same pattern between the three sides. That's why it's a special triangle. So the other type of special right triangle is called a 30, 60, 90 triangle. So just like we call the isosceles right triangle a 45, 45, 90, 30, 60, 90 is called that because of the angle measures. The angle measures are 30 degrees, 60 degrees, and 90 degrees. And the 90-degree angle is the reason that it's a right triangle. So we also have a side pattern for 30, 60, 90, but it's going to be different than the side pattern for the isosceles right triangle. So the shortest side is across from the 30-degree angle. So if we call this side X to start our pattern, right here across we have the X. The longer leg is equal to the shorter leg times the square root of 3. So that makes it X times square root 3. So that's across from the 60-degree angle. It's the square root 3. And then the hypotenuse is equal to the shorter leg times 2. So it's 2x. The hypotenuse is always across from the 90-degree angle. So again, to give you some examples here, if this shortest side was 3, that would mean the hypotenuse is twice that, it would be 6. And to follow the pattern, this would be 3 square root 3, which take that x and we put it right in front of square root 3. If this side across from 60 was 8 square root 3, that would make this side here 8. And to follow the pattern, that would make the hypotenuse 16. Alright, last one, if we knew that the hypotenuse was 200, that would make the shortest side 100, and that would make this other side 100 square root 3. So it always follows the same pattern. So across from the 30 we have x, 60 we have x square root 3, and 90 we have 2x. And again, these line up. So across from the 30 is the shortest side, across from the 60 is the x square root 3, and across from the 90, the hypotenuse, is 2 times the shortest side. Or we can think of it to make it easier as 1 square root 3 and 2. Right, and they'll always have that same ratio. Always follow that pattern. One thing about triangles, we can see this from the side pattern here, but it's true for every triangle. So just a note at the bottom. The smallest angle in a triangle is always opposite the smallest side. And same thing, the largest angle of a triangle is always opposite the largest side. And then obviously the in-between angle and the in-between side line up as well. So when we say opposite, just like with the 30, 60, 90, what we mean by that is across from. So if we had a triangle, this angle would be opposite this side. It's across the triangle from that angle. most of these you're going to do on your own. We're just going to do 2 of these together just to kind of give you an idea of how we use this pattern. So for this first one, I'm finding the missing length. So I can see here I have 2 equal sides. And it's a right triangle, so this is the 45, 45, 90 triangle. Or the isosceles right triangle. So I know my pattern should go 1, 1, square root 2. So here I've got 4 and 4, so the missing side should be 4 square root 2. So we're just trying to follow the pattern, find what pieces we have and what piece we're still missing. So this piece we had, this piece we had, right? So it lined up with these two. We had ones across from the 45-degree angle. We're missing the hypotenuse across from the 90-degree angle. So if I look at this next triangle, I have 4 for one of the legs and I have 8 for the hypotenuse. This one matches up with the pattern for the 30, 60, 90 triangle. Right, that pattern goes 1, square root 3, 2. So here I can see that 4 and 8 fit the pattern like 1 and 2. Right, this is across the 90, which means that the 4 would be across from the 30. Which means this angle up here will be 60, and my missing side, the missing piece of the pattern, would be 4 square root 3. This will be a little tricky at first, but the more you work with these, the more it'll start making sense, the more you'll recognize the pattern, and this is something you'll come back to again in Math 2. So if you want to see some other videos or do some more examples, you can look for special right triangles.